Okay, hi everyone. My talk's going to be on the impact of mineral exploration on ecosystem characters and Mallee vegetation in Pinkawillinie Conservation Park in South Australia. This study was for my PhD and my supervisor was Jose Pacelli. Now with mineral exploration in this area, in Pinkawillinie, there's been approximately 240 line kilometres of access tracks cleared, and this clearance is over tenements in a number of areas. The clearing is done by concrete rollers being towed behind a tractor and therefore squashing the vegetation. And the holes are drilled along the access tracks. And this prospecting is for gold and copper. Okay, so with this sort of linear disturbance, there are characteristic impacts due to the large edge effect. So the edge to surface area ratio of the disturbance is quite high. And there's patchiness to the environment caused, and this results in internal fragments in an already fragmented environment. And there's links between the environmental characteristics and physical disturbance, and little is known on the effects of ecosystem functioning, particularly in this sort of circumstance where you've got a number of tracks cleared and they're often quite close together. And there's a likelihood of the subsequent expansion of the initial area of disturbance due to the synergistic effects on the ecosystem as a whole. With mineral exploration, there's very little quantitative data on it. There's quite a lot on mining practices, but there's really not much on exploration, which is an important gap in our knowledge. Okay, here you can see this is my field site, and it's up here, that's just a satellite image. You can see the grid of tracks if you look carefully, and it's called Baggy Green. The company that has done this is Adelaide Resources Limited, and this is one of the tracks that were cleared for exploration purposes. This one here is in the similar area, and you can see here how much damage erosion has caused, and that will just stay like that and get gradually worse and worse due to the soil structure. Okay, the questions that I asked were, why is there very little perennial vegetation regenerating on the tracks? And this is often a long time after they've been cleared. And what's the likelihood of weed invasion? And what are the environmental factors that affects this likelihood? And how does the topography affect the ecosystem functioning in relation to this linear disturbance? And also, of course, what future research should be done to enable the impacts to be remediated. Okay, Pinkawillinie Conservation Park is in the mid-north of Eyre Peninsula. It's a semi-arid environment. It's dunar country, and it's never had agriculture in it because of the low nutrient status of the soils. And there's been a little grazing towards the south end of it, but really not very much at all, as there's no surface water. Okay, I chose 3 tracks of similar characteristics, and I chose a section of 100 metres. I took samples and measurements from the sections down the track of crest, slope, foot slope and swale, and across the tracks of centre, wheel rut, shoulder, and in the undisturbed area, which is 5 metres out. Now the features I looked at were the physical features of compaction, moisture and erosion, and the nutrient status of the soil in terms of total nitrogen and potassium, and the vegetation in terms of perennials, the mature population and seedling regeneration, and also potential for weed invasion, microflora in terms of soil crust and mycorrhizae, the litter and annual seedlings and germinable seed bank. I'll talk about the first 2 in this talk. Oh. Oh, okay. So, firstly, with the physical aspect of compaction, you can see here that in the wheel rut, the compaction is really quite quickly at the maximum level that the device would measure. That's at 10 centimetres, and that's the swale, which is this orange line, is the one that became compacted the most easily. And in the undisturbed area, you can see that the compaction, is is much less. Okay, so the soil moisture was much higher. The water content of the soil was much higher on the tracks than in the undisturbed area, and the wheel rut had more soil in the more water in the soil than the other positions, particularly in the top layer. The water was held in the more compacted areas for much longer than the other positions. I measured with probes, soil moisture probes over time, and it showed the rate of drying out, and I'm not talking about that. The physical aspect of erosion, in the first 2 years of the study there was drought and there was no soil movement down the tracks, but then in the third year there was torrential rain in summer, and there was a large amount of soil moisture down the tracks, soil water down the tracks, so soil movement down the track, so you can see that in that graph. And this is quite pertinent in terms of climate change, because if we're going to have long periods of drought and then substantial summer rains after a winter of no rain, there's going to be a potential for more erosion. So here's a summary slide of the track being cleared. It results in high soil compaction, which therefore reduces water infiltration, increased runoff of water, and therefore soil erosion. This is exacerbated by the stability of the soil being changed on the tracks due to no soil crust, and mycorrhizal content was less on the tracks than in the undisturbed area. Okay, the vegetation of the area consisted of an upper strata of Calatris verrucosa, a native pine, a mid-layer of mainly Melaleuca uncinata, which is broom bush, and a ground layer of Triodia mainly. The perennial seedlings are studied by tagging a number of them and measuring their mortality over a period of 28 weeks. You can see here that there's a loss of living perennials on the tracks over time, and is particularly in the swale and the foot slope, which are the more compacted areas. Okay, here you can see that I looked at the perennials in terms of the dicot survival rate and the monocot survival rate. There are a lot more dicots surviving over the period of time than monocots. And the mortality was actually different for different species, resulting in a change in the relative abundances. You can see here that at the swale, initially, this is the initial number of perennials, you have more monocots than dicots. At the crest, you have more dicots than monocots. After the 28 weeks, it's reversed at the swale and at the slope, and the crest there's no difference. Now, with the swale soils, they were more compacted, so there's a chance that the perennial dicots have a deeper root system and therefore can withstand, they're just healthier in the compacted soil than the shallow-rooted monocots. And on the slope, there was that soil movement down, so the shallow-rooted monocots aren't going to stay there and they just move down with the soil. In terms of weed invasion potential, I looked at Coryctera annua. I collected samples of soil from all the positions on the track, took it back to the glass house and measured the growth of seeds of Coryctera annua, which is a common agricultural weed from around the area. It was quite a sort of strong difference between the amount of growth of the weed in the swale than in the crest. And with my nutrient analysis, I found that there was a larger amount of potassium and nitrogen in the swale than in the crest. So there could be a relationship there. So this is just a summary, but it shows how complex the different characters and change of those characters are and interact with each other to produce the end result, or possible end result. The conclusions that I found was that there was a high mortality of regenerating perennial seedlings, and this is due to compaction, reduced infiltration and erosion. The first place where weed invasion is likely to take place is in the swale, and this is due to the higher concentration of nutrients. And all this data has indicated different transport processes occurring on the tracks than in the undisturbed area. And therefore there's been a resultant redistribution of nutrients and propagules of plants. So the strategies to minimise these impacts, I suggest clearing tracks by rolling vegetation instead of taking off the top surface with bulldozers. In this situation, they have done the rolling of vegetation, and there has been some regeneration from rootstock that's still under the tracks, under the surface of the soil. The tracks could be cleared at an angle to the dune face instead of up and over, just to reduce the slope and therefore reduce the chance for erosion. Also, tracks should be cleared around major trees. That was done in this situation as well, and it really does mean that the tracks got less of a straight line for soil movement. With the introduction of weeds, the swales are the place that should be monitored over time, and that's when I was there were very few weeds. Actually, there weren't any in the areas, but the chance of them being introduced is very high. The compaction could be alleviated by shallow ripping, and that would be in the swale and wheel ruts. And with the clearing of the tracks, there's often vegetation is just pushed to the side, and that could be put back on the tracks after the tracks have been finished being used. Another important thing is the entrances to the track. Tracks need to be disguised because that locals would use it for recreational purposes, cause havoc. Okay, and for future research, with a view to restoration, it would be great to have another project where the actual methods of ripping, because I didn't really study any restoration methods, could be analysed to see the depth of ripping that would be needed and just the type, because there's a calcrete layer underneath the top surface soil, and that definitely you don't want to be bringing that to the surface, which has happened in places. So also the introduction of weeds is a problem, so it would be good to look at the various methods that it's a possibility that they're coming in, the seeds and propagules, and for that to be mitigated, and also to monitor the swale soils of tracks over time, just to see how seasonal variation could affect the introduction of weeds and proliferation of weeds there. Also, I looked at the mycorrhizal content of the soils, but that would really warrant further investigation. Mycorrhizae are a very important part of the system in Mallee sort of vegetation areas, and yeah, to do more research on that would be great, to see if the mycorrhizae stay in the soils after clearance, and therefore they're viable to go again if there is any regeneration. Also, the influence of litter on the tracks would be interesting to look at further, to see how much it increases the sites for seeds to germinate, and also to mitigate the amount of soil movement along the tracks. And I'd like to acknowledge Sue Carthew as my second supervisor and my field assistants. Okay, thank you.